Hi everybody, welcome to lesson 2 where we're going to focus in on arithmetic sequences. So remember, arithmetic sequences are all about adding when you have an additive pattern. So try this opening exercise and then we'll get started. State the pattern and find the next 3 terms. So hopefully you realized the pattern here is we add 3 to get the next term. There's an add 3 pattern here. And make sure you told me start at -7. So when you describe a pattern, there's 2 parts. You have to tell me where to start, where's home base, and how do I get to the next term. So +3, +3, +3. So today we're going to focus on writing explicit rules, explicit formulas for these arithmetic sequences. So in the last lesson, I talked about how explicit is a formula that you plug into. You plug it in to find the explicit, to work with explicit formulas. Pretty much every formula we've worked with up to this point has been explicit. You just plug numbers in and it spits out the answer. So consider the sequence in the opening exercise. So it's -7, -4, -1, 2, 5. So this is like a sub 1 here, so I'm going to call home base. How many jumps do I have to make to get to a sub 5? 1, 2, 3, 4. So watch what I'm going to write. A sub 5 equals, I started at -7. I added 3. Each jump here is adding 3. How many times did I do that? Notice it only took me 4 jumps. 1, 2, 3, 4. It only took me 4 jumps to get there. -7 plus 12 is 5, as we expected it to be. So using this idea, let's get to a sub 10, the 10th term. So let's start at home base of -7. I keep adding 3, but how many jumps is it going to take me to get to the 10th term? It took me 4 jumps to get to the 5th term. It's only going to take me 9 jumps to get to the 10th term. -7 plus 27 is 20. So the 10th term in this list of numbers, if you sat there and kept doing +3, +3, +3, +3, the 10th number in that list would be 20. Well, let's make it fun now, and let's do a sub 2020. So where do we start? We start at -7. I keep adding 3, but how many jumps is it going to take me to go from the first term all the way to the 20th term? Well, it's going to take me 2019 jumps to get there. And this I definitely need a calculator for. -7 plus 3 times 2019 is 6050. Nice number. So if you kept going and got all the way to the 2020th number, it would be sitting in that little seat there would be 6050, 6050. So using this idea, let's write a formula for any term number n. If I want to get out here all the way to the nth term, how many jumps am I going to have to make? Well, we start at -7. I keep adding 3, but notice it's always 1 less. So it's going to be n minus 1 jumps. This is my explicit formula. This is my explicit formula for this arithmetic sequence. In general, what was that -7 representing? That was representing the first term. I kept adding on that 3. That 3 is called the common difference. Remember, that number we keep adding is called the common difference. The number we keep adding is called the common difference. And then there's the n minus 1. Fortunate for us, New York State gives us this formula if we were to take a Regents exam. Who knows if that's happening? But as of now, they're on. As of when I'm making this video on March 20th, Regents exams have not been canceled yet. So on your reference sheet, you'll be given that. You just need to realize when to use it. We use it for arithmetic sequences. So here's that formula again. The nth term in a sequence, in an arithmetic sequence, is the first term plus the common difference n minus 1 times. So given the sequence, state the common difference and write an explicit formula. So what's the pattern here? The pattern is add 4. So I have a common difference of 4. Well, we're done. A formula for a sub n. The nth term is home base, start at -2. I keep adding 4, but if I want to get to the nth term, it's n minus 1. I could clean this formula up by distributing, but I'm not. You could distribute the 4 and then combine like terms, but I'm not going to do that right now. State the common difference or write an explicit rule. So pause the video, and for each of these sequences, state the common difference and write me the formula for a sub n, the explicit rule for the nth term. Did you really pause the video, or did you just... All right, I'm going to trust you that you paused it. So the common difference here is -5. I keep subtracting 5 each time. So the nth term is start at 4. I keep subtracting 5. I need n minus 1 times for that to happen to get to the nth term. The common difference here is 2. Keep adding 2. So the formula is start at 10. We keep adding 2, n minus 1 times. This isn't that bad, is it? Is it going to get worse, sir? Of course, but not too bad, not too bad. Here the common difference is -4. Here the common difference is -4. I keep subtracting 4 to get to the next term. These are all arithmetic sequences I'm working with here. Start at -6, keep subtracting 4, n minus 1 times. That wasn't bad, was it? The last video got a little long, so let's just skip 4. Last video got a little long. I'll compensate right there. And I want to focus on the important stuff. And I want to overwhelm you guys with superfluous problems that we don't really need to do. So in an arithmetic sequence, when I'm adding, there's an additive pattern. What does this mean? A4 equals 19. Well, that tells me the 4th number in my list is 19. And the 7th number in my list, 4, 5, 6, 7, is 31. I need to write a rule for the nth term of this sequence. So watch what I'm going to do here. I know it's arithmetic, so I'm adding the same number each time. I'm adding that common difference each jump there. So now I can write an equation. 19 plus 3 jumps, 19 plus 3 common differences gives me 31. Look how this picture made this equation for me. Start at 19, and you keep adding the common difference to get to 31. And then we can all solve two-step linear equations because we passed 7th grade. I got a common difference of 4. So apparently I need to add 4 to get the next term. Yes, I do. But to write the formula, I've got to get back to home base. How do I get back to my home base of the first term here? Well, instead of adding 4, subtract 4. 7 plus 4, n minus 1 times. Not too bad, not too bad. Oh, Simone lost his library card. Oh no, and he has an overdue library book. When the book was 5 days late, he owed $22.50. So 5 days late was not 22, $2.25. That's a very expensive. $22.50 would be very expensive to replace his library card and pay the fine. When the book was 21 days late, no, Simone, you got to find that book, bud. It jumped up to $6.25. So suppose it's an arithmetic sequence. Write me a formula here. Write me a formula for this here. So how many jumps do I go from day 5 all the way to day 21? Wasn't that 16 days gone by? 16 days went by. And how much did it go up? We're kind of finding, we're not kind of, we actually are finding the slope of this line here. Remember, arithmetic sequences are linear. We have to find that rate of change. What do I keep adding? Well, it went up $4, right? That's plus $4. So it went up $4 in 16 days. $4 in 16 days gives me 25 cents each day. 25 cents each day. That's my common difference here. So 225 on day 5, 4, 3, 2, 1. We got to work our way backwards here. Minus 25 cents, minus 25 cents, minus 25 cents, minus 25 cents. So the formula A sub n, oh, Sparky's not happy. A sub n equals the first term. How did I get the first term? I worked backwards. I started from day 5 and I worked backwards in that arithmetic sequence there. We add the common difference n minus 1 times. That lets me deal with Simone. Use this formula to determine the amount of money Simone needs to pay when the book is 60 days late. Well, this is an explicit formula, so all we have to do is plug in 60 days. 60 minus 1. If I want the 60th term, it's going to be 59 jumps. That's the 59 there. 1.25 plus 25 times 59 is, it's going to cost them 16 bucks. I hope this book was worth it to have a $16 late fee. You might as well just keep it at that point. So arithmetic sequences are all about adding. Arithmetic sequences are all about adding, and we can write explicit formulas by starting at A1, adding the common difference, n minus 1 times. That's how we deal with arithmetic sequences. I'm just going to quick peek at the homework. Yep, we're good to go. So see you guys in lesson 3.